All right, so you did a poster session on simple interest and to find out how much money you'd have in your account after 1 year. And what I want to do is talk about the formula just a little bit. So you used probably this formula, I equals PRT, and that gives you the amount of interest that you're going to earn on your account. And then what you had to do was take your starting value or your principal, add in that interest that you got here, and then that would give you the total amount in your account at the end of that time. Now, there's another way that you can do this. If you want to just find out the total amount that you'll have in your account at the end of your investment period, you can use this formula, F equals P times 1 plus RT. And what I want to do is show you why that's the same thing. If I take this P and distribute it inside the parentheses, then I would have F, which is standing for the future value or the value at the end of your investment period. So we'd have P times 1, which is just P, and then P, and then it'd be a plus in between, and then P times RT, so PRT. Now, that is just the big I from our previous formula, the PRT, the principal times rate times time. That's the same thing here. And then the P is that big P right here. So these are exactly the same thing. It's F equals principal plus interest. Same formula, this one just goes a little more directly and starts with your principal and then combines the interest with the principal amount and gives you a final value for the end. So that one's a handy one to use, so I'm going to go ahead and show you how to use it on this problem. So we'll use this formula, F equals P times the quantity 1 plus RT, and it might look kind of familiar like the percent increase formula as well. Okay, so the F is the future value and the P is the present value and the R is the rate and the T is time in years. So what we would like to do is figure out where each of the values come from in our problem and put them into the formula and calculate. So we're in 4 years, so I see that first, in 4 years, so that's how many years, and it sounds like time to me, so that's going to be down here for time in 4 years. You plan to use, so you plan to use, so you don't have it yet, so you want to end up with the $6,000. That tells me that's the future value, $6,000 for a down payment on a new pickup truck. Interesting, but we don't need it for our formula. To accomplish this, you purchase a government bond that pays 5.75% annual simple interest. Now this phrase here, simple interest, tells me that I should be using my simple interest formula. The 5.75% annual means that is my rate. My rate is 5.75%. And remember, when I use a rate in a formula, I need to convert it to a decimal. So I'm going to divide by 100, so it'll be 5.75 divided by 100, which would be 0.0575. And that'll be my rate to use. And then I need to find, let's see, each year, what is the present value? Oh, and there it's telling me we need to look for the present value, so that's the P I'm supposed to find, having a future value of 6,000. So that just is reiterating for me the 6,000 is my future value and 4 years is my time. So I have all the values I need, I just need to plug it in now. So I'll have 6,000 equals P, the big P, I don't know what it is, and then 1 plus R, my R is 0.0575 I'm going to multiply that by time, which is 4. And so my formula looks something like that. Now I want to start plugging things in and calculating there. So I'm just going to, this formula is pretty straightforward. There's nothing very special that I'm doing on my calculator, so I'll just show you with the computer calculator. I have 0.0575 times 4, that's inside the parentheses, and it's multiplication, so I want to do it first. So 0.0575 times 4. The reason I said it's multiplication is because that means it comes before this addition here, so I need to do that calculation first. So times 4 equals, and I get 0.23. Now my problem looks like this. 6,000 equals P times the quantity 1 plus 0.23. Well, I can just add 1 plus 0.23, so 1 plus 0.23. Or remember I had 0.23 sitting on my calculator, I could just leave it there. Sometimes the decimal goes on, and we really don't want to lose any of the decimal points, so we would leave that sitting there and then just say plus 1. So I would do the plus 1 equals, and then I have 1.23 times the P equals 6,000. Now the next thing I want to do is get that P by itself, so I want to divide both sides by 1.23, and so the 1.23's cancel on the right, and I have P equals, let's try it out, well, I'm going to have to type this one in, but I will show you another way that you can do this problem so you don't have to retype that number, because like I said, when it's got a lot of decimals after it, I don't want to lose the precision that I have. So 6,000 divided by 1.23, and I get a long number, but it's 4878 point, let's see what the rest of it was, 0.0487. So I want to round to the nearest penny because this is money. So I'm looking at that 4, that would be the nearest penny, and I look at the digit after, it's an 8. So I'm going to have to bump the 4 up to a 5 because this 8 here in that position is 5 or greater, so I have to bump up the number before it, or the pennies. So 4 cents, 0.8, and so it has to be 0.05, so 0.05, and that's how much money I have. Now I said I was going to show you one other way on the calculator. I want to go ahead and do that. When I'm at this point, 6,000 equals P times the quantity 1.23. Remember, I wanted to divide by 1.23, and I'm going to tell you that is the same thing as if I think of that quantity as being over 1 and multiplying by 1.23, but having that in the denominator so that those two cancel. So if I do that on the right, I would want to do that on the left as well. And this is where my calculator functions come in, where I don't have to get rid of the 1.23. So pretend it was a big long decimal that I didn't want to lose the precision. And the reason I keep saying that, I don't know if I mentioned this yet, but when you do a calculation on the calculator, it shows you maybe 7 or 8 digits, but it's storing at least twice that in the calculator memory, and you can't see it, it's just being stored. So if you write down just the 6 or 7 digits that you see, and then you go ahead and use that for your next calculation, you could be losing some of the precision. And especially when we get to some of the more complicated formulas towards the end of this chapter, we need to keep every decimal point that we possibly can so that we don't get an answer that's way off from what the actual answer is supposed to be. Okay, so we're going to spend a lot of time up front when it's the less difficult problems so that you can get used to using the calculator in the way I'm showing you, so that when we get to the later sections it won't mess you up. All right, so what we want to do is multiply both sides by this quantity, the 1 over 1.23. And to get that on my calculator, I have the 1.23 sitting there. And then I'm just looking for this button, see that 1 over x button. You may also see it, and here it is on this calculator, as the x to the -1 button. And if you've got that button, it's the exact same thing. So what I'm going to do is with the 1.23 that's sitting on my calculator, I'm going to use the 1 over x button or X to the -1 button. You might even have, I think there was another one, like X to the Y. I don't know for sure, but I know these two buttons for sure will get you what we're after. 1 over X and X to the -1. So either of those two buttons, push that, and so on our calculator, I'm going to pull that up one more time, push that 1 over X button, and I get a big long decimal, which is the equivalent of taking 1 divided by, let's do it. So it's the equivalent of taking 1 divided by 1.23. And there it is again. We'll do it one more time. Remember, it's 0.813. So we'll do 1.23, use that 1 over X button. See, it's that 0.813 and some zeros and ones. Okay, so this decimal value then is the equivalent of 1 divided by 1.23. And so now I have that whole thing here is this 0.813, and it goes on and on. I'm going to now multiply that by the 6,000. So on my calculator, I'll just now say multiplied by 6,000. I'm going to show you one more time just so you can see it again. And there I get the 4878.05 once I do my rounding. Okay, so clear this out. Let's do it another time. I have back here, I have P times 1.23. So I have the 1.23 sitting on my calculator. I do the 1 over X button to take the inverse, it's called, of that number, or the reciprocal, that's another way of talking about it. And then I'm going to multiply by what's on the left-hand side, or the 6,000. And then I get my result that way too. I want you to practice that. I want you to try it. I want you to work it that way as many times as you can until you get comfortable with what you're doing. I normally would be back here dividing by the 1.23, but I switched it so that I'm multiplying by the inverse or the reciprocal of 1.23. So multiply, I change it to multiply, and I'm using this fancy button on my calculator to get there. So 1 over X to get that. Okay, so two ways of showing it to you, but in 4 years, oh, I need, let me rewrite that. I need $4,878.05 to end up with $6,000 in 4 years. Now that's a pretty good interest rate, 5.75%. So if you can find something like that, you're pretty lucky.